Hey guys, what's up? So today we're going to be covering quadratics, the last part of the quadratics. Sorry, this is coming out really late in the week. I'll try to get it up earlier next time. But let's just kind of jump in really quickly. So first things first, we're going to be talking about polynomials and about how to factor them. Last class, we talked a little bit more about factoring them, but today we're going to go into some special cases. So here's the major idea for the day. There are special patterns to look for when you're factoring polynomials that give us these little shortcuts that make it a little easier. Hopefully you guys already watched the 3 videos on what's it called, slide and divide, quick factoring, and AC factoring, and you've chosen one of those 3. You want to get really good at it. Everything that we're doing today can be solved using one of those 3 methods. However, these here are just shortcuts to, again, make it a little bit quicker, and hopefully you guys get used to the pattern recognition. So again, if you could have done last lesson, this lesson is exactly the same. The only difference is that now we're going to try to see if we can find these specific patterns. So let's jump in. First off, the first pattern we're talking about is something called factor by grouping. Now, if you watch the AC video, I talked about factor by grouping in there. So this is just kind of an expansion upon it. So basically what's going on here is the way you can tell that you're going to want to use factor by grouping is you check to see that there are 4 terms. Now what 4 terms means is something separated by a plus sign or a minus sign. So we have 1, 2, 3, 4 different little objects here that are separated. Those are your 4 different terms. Now, how can you tell if it works? You're allowed to double factor. That's our sanity check. If you watched my AC video, you know what I'm talking about. If not, we're going to show you how to do that right now. So let's kind of look at this really quickly. Here's the basic idea. We have x squared plus 4x plus 3x plus 12. Now, all you're going to do is you're going to group the first 2 and you're going to group the second 2. That's it. You group the first 2 and you group the second 2. And then you see, what can I factor from here? Now remember, factoring also means undistributing. We did that before, so that's all we're going to do here. What do both of these have in common? Well, this has 2 of my x's. This has 1 x, so we can take that out. We can unmultiply the x. And once I take away the x, I'm left with x plus 4. Once that's done, there's a plus here. And then we say, hey, look, there's a 3 and a 12. Both of these numbers are divisible by 3, so I'm going to unmultiply or undistribute my 3, in which case we're going to get x plus 4. Now, if you don't know how to undistribute, go watch one of my previous videos where I talked a little bit about it, specifically the AC factoring one. I went a little more in depth. You're going to break it down using prime factorization, find what's in common, and unfactor it. If you don't know how to do this, please look up prime factorization or send me an email. I can explain it to you guys a little more in depth. Now, once this is done, basically you have x times this number x plus 4. You have 3 times the number x plus 4, which means they're both being multiplied by the number x plus 4. Now, the reason I say the number is because when we're working with parentheses, everything in it is a group. We think of it as if it were only one number, which is why I'm saying this is one number. Now, they're both being multiplied by it, which means we can undistribute it. So we're going to have x plus 4. We're going to undistribute that. And once I take those away, what's left over is there was an x in one and a plus 3 in the second, and this is how we factor. Now, when I said earlier, how can you tell it works? You can double factor. If these 2 here are not the same, that means there's just no way to factor. We're just stuck there. But the fact that we can double factor it, that they both match up, that the x plus 4 here matches up with the x plus 4 here, and we can take it out, that is how we know we're allowed to use factor by grouping. So again, super quick rundown. When we're factoring by our first pattern, we're looking for grouping. The way we can tell we're looking for grouping is we look for 4 terms. After that, the way we know we're allowed to actually do it, because it doesn't always work, is that after we factor the first time, there will be something in common, like this x plus 4 that we can take out again. Okay, that's the first one. The second one is factoring by difference of squares. Now, if you watched, again, the last video, it should have been talking about difference of squares and the pattern of difference of squares. So let's talk about the general term or the pattern of difference of squares. Difference of squares means we have number plus number times by number minus number. And the only difference here between the left side and the right side is that one's a plus, one's a minus. And when you FOIL this out, the pattern says that, hey, if it follows this pattern, all that's happening is you're going to get something like this. Now, let me show you what that looks like. Again, we should have covered this already. That's why I'm going through it really quickly. But we have number plus 2 times by number minus 2. Hey, look, they're the exact same thing, but one is plus, one is minus. Now, according to the pattern, instead of having to FOIL this or multiply this out, all we're going to do is just say, well, I just take this times this. So 3 times 3 is 9. Then I take x times x, which is x squared. That's what this first one is saying. We take the number squared times by the variable squared minus whatever this second number here is, which is 2 in this case. So 2 squared is 4. So we didn't need to do any heavy lifting. We didn't need to do anything really. We just followed the pattern. That's our difference of squares patterns. Now, again, if you're not sure about how I got this, feel free to message me, look up difference of squares on Khan Academy, or you're totally welcome to watch my last video where I talked about difference of squares as well. All right, now that's how you multiply using difference of squares, the patterns of difference of squares. Now, instead of multiplying here, what we're going to do is we're going to factor, we're going to unmultiply. And what we're doing here is we notice, hey, look, I have a squared like this, an x squared like this, and a minus squared like this. So it fits our pattern, so we can just undo it. So according to my pattern, this should factor into something like this, where 1 is plus, 1 is minus. And we say, okay, what is 25 the perfect square of? 25 is the perfect square of 5. It's 5 times 5. So we're going to just set that up. 5 and negative 5. And what's 4 the perfect square of? And the answer is 2. And then finally, x splits up into each of them individually. Now, this is why I was saying it's so important to be at least familiar with your first 10 to 12 to maybe 15 perfect squares, because if you didn't notice this, you would have to do it the long way. So whenever you guys are trying to factor by difference of squares, always look to see, hey, look, if I only have a squared and I only have a number, so I don't have any x values here, no regular x values, only x squared values, and they're both squares, then we're allowed to use it. Okay, that's how you factor using difference of squares. Again, you can use slide and divide. You can use all of them. All of them work. It's just in this case over here, this is just a shortcut. All right, so here, again, this is the key. Whenever you guys are doing difference of squares, if you see two terms and there's subtraction between the two terms, that's when you start thinking, maybe I'm allowed to use difference of squares here. Now, the way that you know that you're allowed to use difference of squares is if both of these are going to be perfect squares. Now, what I mean by that is this is a perfect square and this is a perfect square. So, for example, if I had something like this, 4x squared plus 9, this one obviously doesn't work. It's obviously not difference of squares because one of my keys is it had to be subtraction. Now, if I had something like this, 4x squared minus 8, this again would not work because 8 is not a perfect square, which is again why it's important to know your perfect squares. All right, last pattern, factoring by perfect squares. Now, if you remember our perfect squared binomials or squaring my binomials, we have this pattern here, ax plus b quantity squared. So that looks something like this. Now, if it does this, the pattern is we take this number and square it. So 2 times 2 is 4, x times x is x squared. Then we go plus 2 times b, in which case this is 3, times a, which is 2, times x. And then finally plus b squared, which is 9. So if I factored this all out, it would be 4x squared plus 2 times 3 is 6 times 2 is 12x plus 9. This is how we factor it. Again, we didn't do any foiling, nothing like that. We just followed the pattern. Now that's how we go forward. Going backwards is a lot more difficult. Now basically what you're going to have to do is the way you recognize this is you say, hey, I have something like this. I'm pretty sure this is a perfect squared binomial. Let's check. I think that a should be equal to 3 because 3 squared is 9. I think b should be equal to 1 because 1 squared is 1. So let's test it. 9x squared plus 2 times 3 times 1x, plus 1 squared. So we have 9x squared plus 6x plus 1. Hey, look, it is a perfect squared binomial. It fits the pattern, so that's why we can just say it should be ax. Now, a squared was 9, so a is going to be 3x plus c, or my b in this case, was going to be 1, so it's 1 all squared. So that's how we factor it. Again, these are shortcut factorings. They're just following patterns. If you're watching this and you're like, oh my gosh, I have no idea how to recognize the patterns, that's totally fine. Do it the long way. You can AC factor, stuff like that. Don't let this trip you up. These are just shortcuts because factoring does take a while. All right. Whoops. So again, main thing. My key is whenever I see 3 terms and my A and C are perfect squares, meaning this is a perfect square and this is a perfect square, then we just test it. The way we test it is we go 2AC should equal B. 2AC equal B. Not 9 times 1 though. That's capital A and capital C. Lowercase a is the square root of A, meaning what times what gives me 9, and the answer was 3. That's A. And what times what equals capital C, what times what equals 1, and that C equals, that just happens to be 1. So we're going to check 2 times A, which is 3, times C, which is 1, should equal to 6. 6 equals 6. Yep, it works out. So if it does work out, then you can use your perfect squared binomial rule in order to go backwards, but it's up to you. Again, I personally almost never use this. I almost always quick factor at this point because quick factoring is quicker than seeing this. But again, these are just shortcuts and things that you can use. So again, if I'm looking at this, real quick example, if you want, what would you try to use here? It's obviously not difference of squares because there's more than 2 terms. And it's not a perfect squared binomial. The one that we always try here is factor by grouping because there are 4 terms. So let's group it up. Let's group these 2 and let's group these 2. So both of these here, the numbers are totally different, so whatever, but they both have an x. So let's take out that x and we're left with 3x minus 2. Then after that, we have 9x and 6. Hey, both of these have a 3 in it, so let's divide each of them by 3, and that's how we get 3x minus 2. Now, in order for me to do this, these 2 parts should be the same. I should be allowed to double, and it just so happens that it works. So because it worked out, we can take that out. So we're left with 3x minus 2. We're going to just factor that out again, and then what are we left with? I'm left with an x plus 3. And then that's how we factor. Now again, factoring is very difficult. I'm trying to keep my videos under 15 minutes, so I know that I'm going to be skimming through a lot of things. If you have questions, feel free to let me know. Also, please make sure that you checked out the Google Classroom. I did send a long post on there asking a handful of questions. One of the questions was if you guys would like a Discord. Some of you guys were saying that Remind and other things are kind of hard to get in contact with me with, and my Geom Honor students really like their Discord channel. So if you want to use that, that's totally fine. Just let me know. If I have enough people that want it, I'll set it up. But if I only have 2 or 3 that want it, maybe I'll roll you guys into the Geom Honors. I'm not sure. I'll have to decide there. So again, let me know your feedback. The more feedback I have, the better I can tailor my class, even online, to what you guys want. All right. See you guys later. Have a great weekend.